Okay, so we're going to prove that A intersection B is equal to B intersection A for any sets A and B. So let's go ahead and start the proof. Okay, so we know that, so we'll have X, right? X is an element of A intersection B, right? So by definition, so we can have an if and only if here because by definition, this means X is in A and X is in B, right? X is an element of A and X is an element of B. So this is like saying P and Q, right? So remember, if we have P and Q, we know this is logically equivalent to Q and P, right? Q and P. So we can actually write this as X is an element of B and X is an element of A, right? We can write that Q and P here, right? Q and P, okay? And then, of course, by definition, this means that X is an element of B intersection, well, let me do that, intersection A, right? So what we have here is we have X is in A intersection B, and then going both ways, we get X's in B intersection A, right? Because we use the definition of each of these terms, or each of these statements, right? So this means, right? So by definition, this means that for every X, right? X is an element of A intersection B if and only if, right? X is an element of B intersection A. And this statement here states that A intersection B is in fact equal to B intersection A, right? So since all these were actually definitions, we could have those if and only if statements, making it a little easier on us, right? Because we don't have to prove it going one way and then the other. We can just do if and only ifs, showcasing this exact statement, which is what we wanted to show. So that is the proof.